Today we are doing lesson 8.4, area of composite figures. Our I can statements for today: I can find the area of composite figures, and I can solve real life problems. So again, we are looking at composite figures, which are figures that are composed of other figures. So things like rectangles, triangles, trapezoids, parallelograms, where we have multiple shapes put together. It's called a composite figure. So for area, if we have one on this grid, we're going to count like we did when we did perimeter for these types of ones. However, the counting is a little different. A full square represents a 1, and half of a square equals 1/2. When we were talking perimeter, that line is longer and we did 1.5. But in terms of area, it's half a square, so it's only going to have half in value. Okay, so we're going to count wholes, we're going to count halves, and then we're going to put them all together. Okay, so I'm going to start with my halves. 1, 2, 3, 4, 5. So I have 5 halves. So 5 times 1/2 is 2.5. So just with the halves, that's going to be 2 an area. Now generally when I'm doing area, I don't like to count them all by ones because it takes a little while. Let's see, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So 4 times 8 is 32. That whole area is 32. So onto my 2.5, I'm going to add on these other ones. So 32 plus, it looks like this part is 9. Plus, let's see, 1, 2, 3, 4. If you want to count them all individually, that's fine, but at the minimum, I need to see the number of halves, what you get when you multiply by half, and then how many holes you have. And if you chunk it into parts like I did, then write down what those chunks are. All right, when I add all of those together, I get 47.5. This is area, so I need a squared on my answers label. I don't want it on the number part, I want it on the label. And if there isn't a label like this one, then it's going to be units. So units squared is our area. All right. Well, let's take a look at number 1 together. We're at least going to get it started together, and then you'll finish it on your own. The weird thing about number 1 is these are not perfect halves. However, when you're counting them, to me, I would count them. These two together would make one whole square. I think these parts together, this little one, probably equal 1 square. So like 1 here, that would probably be 1. And then maybe these guys are 1. So I maybe have 6 halves. So when I piece them together, I get 3. Okay, that's our halves number. Go ahead and pause the video, finish number 1 for the area, and then find the area of number 2. Number 2's half squares are perfect halves. All right, let's go ahead and check our answer. So I have 3 for my half squares approximately. Then I'm going to add on my other one. So let's see, I've got 4 up here. Let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6. So this would be 18. And then let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this one isn't quite a whole one. But if I had this little extra part, it would be. So I'm going to count that as 12. All right. So now we're going to add our parts together. So 3 plus 4 plus 18 plus 12 gives us an answer of 37 units squared. Now on a test, you won't see ones like this one where the halves aren't perfect halves. However, if you want to know an exact answer for one like this, I'm going to erase what I have here. Then another way to do that and to know exactly what the area is to split it into shapes you know and find the area of those shapes. So if I wanted to, if I did this triangle, area of a triangle is 1/2 base times height. I'm just going to label that triangle. So I could count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And I could say 1/2 times 6 times 5 would be 15 for that part. And then I could add it to my 4 from up here and my 18 from here. And let's see, 15 plus 4 plus 18 does still give us that same answer. So if you don't have one that's perfect halves, then that's another good strategy for you to use. Okay, let's go ahead and take a look at this one. All right. I think for this one, I'm going to use the strategy of splitting it into shapes that I know. Now, you might have used a different strategy, and that's fine. I have to do it this way. All right, so the way I drew my lines, I've got 3 trapezoids and 1 rectangle. For a trapezoid, my formula for area is 1/2 times the sum of the bases, base 1 plus base 2, times the height gives me the area. And the bases, base 1 and base 2, are the 2 sides that are parallel. So let's see, for my trapezoid 1, I'm just going to write number 1 here, and then I'm going to write number 1 down here so my work matches up. I'm going to do 1/2 times, let's see, this base is 1, 2, 3, 4, 5, 6, 7, 8. That part is 8. And this is 1, 2 on the top. And then the height is the distance between the 2 bases. On this one, my height is kind of up and down, or side to side here, 1, 2, 3. Okay, 8 plus 2 is 10. Times 1/2 times 3. 1/2 of 10 is 5. Times 3 is 15. So this whole part is 15. Let's see, I counted that as 8. 1, 2, 3. This part would be 24. And then these two are the same. So for that one, let's see, I've got 1, 2, 3, 4. 1/2 times 4 plus 1, 2. My height is 2. Four plus 2 is 6. 1/2 of 6 is 3 times 2 is 6. And if that part is 6, then this part is also going to be the 6 because they're the same. So I have 15 plus 24 plus 6 plus 6, and let's see what that gives me. So 15 plus 24 plus 6 gives me a total of 51 units squared. If you counted individual squares, you should have still gotten that same answer. All right, let's take a look at ones that don't give us a grid. So we're going to find the area of each individual shape, and then we're going to add them together. So for each one of these shapes, I like to draw the shape and I like to write the formula and then do the work. So let me show you what I mean by this. It says find the area of the portion of the basketball court shown. So this picture. We've got a half circle and then we have a rectangle. This little blue part actually overlaps in both, but I think it's going to be easiest for me to see this as one full rectangle and one semicircle. Okay, so for the semicircle, our formula is going to be pi times diameter divided by 2. So let's see. Pi will use 3.14. My diameter is 12. If this part of the rectangle is 12, then this part of the rectangle is 12. Divided by 2. Okay, so let's see. 3.14 times 12 gives me 37.68. And then when I take that and I divide by 2, I get 18.84. That's for this part, the half circle. Now I need to do the rectangle. The formula for the rectangle is area equals length times width. My length is 19, my width is 12. So I'm going to do 19 times 12. And 19 times 12 is 228. Now I need to add my two parts together. So my rectangle area, 228, plus my semicircle area. And that's going to give me my total area, which is 246 and 84 hundredths. And that is going to be feet squared. Don't forget that square unit. If the answer is area, your label needs to be squared. Okay, let's try another one. Find the area of the figure. So we're going to split it into shapes that we know. I'm going to do a triangle, a rectangle, and a parallelogram. So we'll start with the triangle. Triangle formula for area is 1/2 base times height. Doesn't really matter which one's base and which one's height, but they do have to form a right angle. Any base and any height on any shape always have to form a right angle. So 11.2 and 4.5, those are the numbers I need. 11.2 times 4.5 divided by 2 because it's a triangle. Okay, so 11.2 times 4.5 divided by 2 gives me 25.2. Okay, now I'm going to do my rectangle. For a rectangle, we have area equals length times width, or base times height. Our length is 8. And our height is 4.5, that's this side. Okay, so I'm going to do 8 times 4.5, and that gives me 36. Okay, and then my last part is my parallelogram. That has the same formula for area as rectangle, base times height. However, on a parallelogram, your sides are not going to be your base and height. One of them is going to come in the middle. You're going to see where that dotted line is. That's going to give you your base and height, where the right angle goes. So 6 7/10 times 8. And that is going to give us 53.6. All right, so we now have our 3 numbers that we need to add for our total area. 25.2, 36, and 53.6. So I'm going to go ahead and add those values together, and I get 114.8 centimeters squared. Okay, go ahead and pause the video and try these two on your own. Okay, let's try this. Let's check our answers. I see a rectangle and a triangle on this one. Rectangular formula is length times width, or base times height. I know 9 times 7 is 63. Okay, if this part is 9, that means this part is 9. And our height on our triangle is 6. Triangle is 1/2 base times height. So 6 times 9. And then divided by 2. It's going to be 27. Okay, then I need to add those together. So 63 plus 27 is going to give me 90 meters squared. All right. So for this next one, number 4, I have 1, 2, 3, 4 semicircles. But if I think about these as being circles, I have these two that equal 1 circle. That looks like 10. I'm going to erase the circle. I'm going to actually write the circle so it doesn't look like 10. Those two equal 1 circle. These guys together equal 1 circle. Okay. So for our formula for the circles, so we have pi times radius squared, and then we're going to take it times 2 because we have 2 of them. These two make 1 circle, these two make 1 circle. All of them have a diameter of 2. We need the radius, so we do 2 divided by 2 gives us 1 for our radius. So we do 3.14 times 1 gives us the area of 1 circle. I'm going to just put in parentheses. That's 1 circle. Times 2, because there are 2 of them, it's going to give me 6 28/100ths for the circle areas altogether. Square is going to be length times width, or base times height. My length and my widths are going to be 2. So 2 times 2 equals 4. These two are the ones that I'm adding together to get my final answer. So 6 28/100ths plus 4 equals 10 28/100ths feet squared. All right, and for our last problem, we're going to take a look at what we need to do if we are missing part of an area. So for this one, to find the area of the shaded region, we have 3 circles, a medium, a small one, and a large one. We're going to find the area of them, and we're going to do some addition and subtraction to find the area of the shaded region. Remember, for all of these circles, it's pi times radius squared is going to give us our area. All right, so this picture is a little hard to understand. This 10 represents to this part. It's the radius of the big circle. So for the big one, we're going to do 3.14 times 10 times 10. 10 is the radius. Okay, and that's going to give us 314. That's my biggest area. Okay, now to find the area of the tiny circle and the medium circle, we have to do a little work. So I'm going to erase this. All right. So we have the biggest circle. Then we cut out the medium circle. We know this part is 5, which means this part, which is the radius of the medium one, is also going to be 5 because it's 10 altogether. So we're going to find the area of the medium one, we're going to subtract it, and that's going to tell us the area of the outside ring. So for this one, we do 3.14 times 5 times 5. And when we do that, we get 78.5. So to find that outer ring, we subtract those two. 314 minus 78.5. And we get 235.5. That's this part, the outer ring. Now we need to find the tiny part because the tiny part is shaded as well. So we said this part from the edge of the white to the middle was 5. And this part is 3. So that means this teeny, teeny, tiny part, that's the radius of our tiny circle, is 2. So we're going to do 3.14 times 2 times 2. And we get 12 56/100. So to get my total shaded area, we have the outer ring, 235.5, plus the tiny little circle there, 12 56/100. And when I add those together, I get 248.6. And that's going to be meters squared. When we're missing areas, there's going to be some subtraction involved.